Okay, welcome back. And now let's do some examples. The first example, they want us to find the magnitude and the angle, the direction of this vector. So let's call this vector v, right? So we'll call this vector v. And so the magnitude of vector v is going to be what? Well, you know what? Let's do this a different way because I don't want to get ahead of myself. Let's transform this into the standard position. Okay, so let's find the position vector. Okay, we could do it directly from the points, but we haven't done that yet. So let's just use the position vector. So again, we want to write the equivalent vector as a position vector. So in this case, we're going to write v is equal to what? It's going to be -2 minus -8, comma, -5 minus 1. Okay? And so now, what happens? Now we're just going to simplify this, and this becomes what? -2 plus 8, which is going to be 6, comma, and then this is going to be -5 minus 1, which is a -6. Okay? So that's where our position vector is now, right? So now we know what A and B are. Now we can go and use the formula for magnitude, which is basically just, which is just the square root of a squared plus b squared, right? A and b are right here. Okay? So, what do we do? Well, let's calculate it. Okay? So, the absolute value of v, so the magnitude of v, is going to be the square root of a squared plus b squared, which in this case is 6 squared plus -6 squared, which is just going to be 36 plus 36, right? Or 2 times 36. So we're going to get 6 times the square root of 2. Right? And so there's the magnitude of the angle. So now, what about, so we have magnitude, right? So magnitude, let's write this down here. Magnitude is 6 root 2. And now what we want to do, we want to find the direction. So that's where the tangent is going to come in. So we know tangent of theta is equal to b over a, which in this case is going to be -6 over 6, or -1. So what the tangent of what angle is -1? Well, tangent is negative in the second and fourth quadrant. Okay? So, if you put this in your calculator, it's going to give you -45 degrees. Okay? Now, the fact that the terminating point is here, right? So it starts here. Okay? Oh, and don't even need to look at that. So we know, again, this is what? 6 comma -6. So based on our standard position, we know it starts here and it's going out here somewhere. So we know we're in the fourth quadrant. And so we know -45 degrees is the correct angle we want to use. Not in here. Okay? So now we've got the direction, which is also -pi/4 in radians. Okay? Or if you want to use the positive angle, it's going to be what? 7pi/4. Right? Is also the same thing. And so that would be the magnitude and the direction. So theta equals negative 45 degrees, or negative pi over 4. And so there's the magnitude and there's the direction. Okay, now, what about these two? Oh, by the way, let's sketch this graph here. So here, negative 45 degrees would be here, right? At 45 degrees. And it would be, the magnitude would be 6 square root 2. Again, obviously we can't draw the whole thing, but it's going to look something like that. Okay? So where the terminal point is right there. So that's going to be 6 comma negative 6. Well, actually, it's going to be way down. It's going to be over here. So I didn't draw it far enough based on my graph. So it'll be down like that somewhere. Okay, so now what about these two? What if we have these two vectors, v, which is represented by this initial point and this terminating point, and then vector u, which is represented by this initial point and this terminating point. We want to know, hey, are these the same point? Okay? And then let's find the magnitude and direction. Well, first of all, one way to show that they are the same point is to just show that they both have the same initial position vector, or not initial position, the same position vector. So let's do that. So here, for v we get what? Negative 1, minus 5, comma, 2, minus negative 3. And so what do I get? I get negative 6, comma, 5. Now let's do this one, see what I get. So u equals, okay, so now I get negative 7 minus negative 1, comma, 2 minus a negative 3. And what do I get? I get negative 7 plus 1 is negative 6. And 2 minus a negative 3, which is the same as 2 plus 3, gives me 5. And sure enough, they are the same, because I get the same position vector. Okay? So they both start at the same place at the origin, and they both end at the same place, which is negative 6 comma 5. So therefore, they have to be the same. Now, another way to do it is just find their individual magnitudes and find their individual direction angle, and if those are the same, then they're equal vectors. Okay, so let's do that. Let's do it that way. Okay. So now, let's find the magnitude of v. Well, we already know that they have the thing. So here's the thing. I'm going to use the distance formula. Because again, the only difference is if I have them in position, then the origin is 0. So remember, the magnitude is just the distance between the 2 points. That's really what magnitude is. Some of you may have already noticed that, but that's really what the magnitude is. So if I wanted to see what the distance is between these 2 points, I would use the distance formula. And the distance formula is given by what? It's the difference in the y's squared. So it's going to be, or you could put the x's first, but it's going to be x2 minus x1, quantity squared, plus the difference in the y's. So difference in the x's squared plus the difference in the y's squared. That's the distance formula. Okay? So if I wanted to do that, well, I would just plug and chug. The only difference is when I'm dealing with standard position, the x1 and y1 are 0. So it just becomes the a squared plus b squared. Okay? So in this case here, I have what? The square root of what? Negative 1 minus 5 squared plus 2 minus a negative 3 squared, right? Look familiar? So look at this. So then we get negative 6 squared. Look at that. There's your a plus 5 squared. There's your b. And so what do you get? You get the square root of 36 plus 25. And so that gives us 61, the square root of 61. And again, do the same thing here. You're going to get the same thing. We get the square root of 61. Okay? And so if you get the square root of 61 for both of them, and then get the angle, let's do the angle. Okay? So if we do the angle, well, let's do u. Let's do u. So the absolute value of u, or the magnitude of u, is the square root of what? The difference in the y's squared, so that's going to be, or the difference in the x's squared, so that's going to be negative 7 minus negative 1, quantity squared, plus the difference in the y's, which is 2 minus negative 3, quantity squared, and now we just simplify. Okay, so this is going to give me the square root of what? This is going to be, again, negative 6 squared plus, and look at this, I get 5 again. So this is also going to give me the square root of 61. And so there you go, they are the same magnitude. Now what about the angle? Well, let's just take the difference, right? We know A and B are negative 6 and 1, so we know that the tangent of theta is going to equal what? Rise over run, remember? Rise over run. Remember, the tangent of the angle is the same as the slope of the line that connects the points, right? So what's tangent theta equal to? It's going to be the difference in the y's, right? y2 minus y1 divided by x2 minus x1. So again, I'm going to do the same thing. So it's going to be 2 minus a negative 3 over negative 1 minus 5, which gives me what? This is going to give me 5 over a negative 6. And so this is where I'm going to take the inverse tangent of both sides, and I get theta is equal to tangent inverse of 5 over 6, or negative 5/6. And that's going to give me, when I use my calculator, that is going to give me, where is it? Negative 39.8. So approximately negative 39.8. And if you do the same thing for u, you're going to get the same thing. And so therefore, it's the same vector. Or the two vectors are equal. Have a great day.